Hi, my name is Kevin G, and I'm here to present piano sheet music identification using marketplace fingerprinting. Given a cell phone image of a page of piano sheet music, our goal is to identify the matching piece in IMSLP. Our system has two main stages. The blue rectangle shows the offline stage, where we construct a database using all solo piano sheet music in IMSLP. The orange rectangle shows the online stage, where we process the cell phone image in real time to output the predicted piece. Note that both stages use the same fingerprint representation. The first step in constructing the fingerprint representation is computing the bootleg score. The bootleg score encodes the positions of failed note heads in sheet music and is a 62 by n binary matrix. Next, encode each binary column of the bootleg score as a 64-bit integer. Then we construct generalized n-grams on the resulting list of integers. While standard n-grams only consider n consecutive elements, our generalized n-grams consider various combinations of n elements selected from a fixed context window size. We consider up to 3 grams for the context window 7, which results in a total of 16 different n-gram types at each offset. For example, n-grams are shown below. Next, we discuss the process of creating the database. In this step, we construct a reverse index for the generalized n-grams in IMSLP. Because IMSLP is so large, we cannot fit all n-grams into RAM, so we have to select a subset of n-grams. To do this, we compute a utility score for each fingerprint by multiplying its probability of correctness with its frequency of occurrence. We sort fingerprints in decreasing order of utility and insert as many as possible into the database until we run out of memory. Then we construct a reverse index for each n-gram, specifying the pieces and offsets where it occurs in the database. For example, this shows that the blue-red 2-gram fingerprint occurs in piece 1 at offsets 1 and 5. Now we'll talk about the online stage. Recall computing the fingerprint representation is the same as the offline stage. Now we look at searching the database. Our approach is motivated by constraints on runtime. For bootleg score query of length L, there are approximately 16L generalized n-grams. Doing lookups in all 16L n-grams would result in a long runtime, so we must select the subset of them. To do this, we use a strategy based on a consumer store analogy. Imagine a consumer in a store with aisles containing goods. The consumer's goal is to maximize utility while staying under a fixed total budget. We calculate a budget per aisle by dividing the total budget by the number of aisles in the store. We then sort the items in each aisle by utility to cost ratio, and purchase items until the aisle budget is depleted. Our fingerprinting scheme is based on this analogy. In our scheme, the goal is to maximize retrieval accuracy while staying under the maximum allowable runtime. We define the total budget as the maximum number of database matches we're willing to process for a single query. Then we divide the total budget by the length of the query bootleg score to get the aisle budget. At each offset in the query bootleg score, we sort the 16 different n-grams by the utility to cost ratio, which equals the probability the n-gram is correct divided by the number of matches it has in the database. Finally, we select n-grams at each offset in descending order until we spend the entire aisle budget. Once we select a subset of n-grams we can process within the runtime budget, the last step is computing a match score for every piece in the database. We use the Shazam histogram of offsets method to construct a histogram of matching n-grams, and use the maximum histogram bin count as a match score. We rank all pieces by their match score, and the rank list is the final prediction of our system. Our database consists of all piano solo sheet music at IMSLP, and our queries consist of 2,000 cell phone images from 200 pieces. We compare the marketplace approach to several other previously proposed systems. Our system has the highest accuracy and lowest runtime of all systems. In summary, we present a novel marketplace fingerprinting system that is able to search all IMSLP solo piano scores with 0.905 MRR and sub-second retrieval time.